Hold on. Okay, so we have coefficients. Coefficients represent what? Moles, because everything is related to the moles. So we are going to start talking about these as mole ratios, just as we can call them coefficient ratios. So looking at looking at 2, so we have 6 moles of A that they're reacting, and it's questioning about D, right? So we want to know how many moles of D are produced or formed. So what is the ratio between A and D? According to the recipe up here. What's the ratio between A and D? 2 to 4, right? So there's, you guys have a paper in front of you, you can't see this. So for every 2 A's, we make 4 D. So I'm basically making what?
A ratio.
But if I'm going from 4 and I'm going from 2 to make 4, I'm doubling it, right? So I'm making twice as much D as I had of A. So it should be quite easy. How do I get to this?
So multiply
by 2, right? So you guys are saying I'm going to make 12 moles of D, because you can think through the ratio. Let me show you another way to write this out in dimensional analysis, which is what this group is talking about. Because basically we're taking this and thinking about it just as ratios, but it's just dimensional analysis. It's just multiplying by something and dividing by something else. So if I have, I'm just going to write up here, if I have 6 moles, and write this down with me so you can see how the units cancel, because remember, we always cancel units. If you have 6 moles of A, right, do your little fraction bar thing. Okay, I'm converting to moles of what? I'm still doing number 2, okay? I'm converting to moles of D, so what do I put on top? Mole of D, okay, and I'm converting and canceling out moles of A, okay. So how do I get the relationship between A and D? The balanced chemical equation, right? So what's the coefficient for A? So I put a 2 here. What's the coefficient for D? 4. So I put a 4 here. What's 6 times 4 over 2? 12. So 4 to 2 is a 2 to 1 ratio, right? 4 to 2 is just reduced to 2 to 1. So like you said, take 6 and multiply by 2. Take 6 and multiply by effectively 2, which gives you 12 moles of D. But though it may not be how you did it, you're translating what you did into dimensional analysis, which we're familiar with. We know how to do canceling units, okay? So I want you to try to set it up like this for the remaining. Okay, keep going. You have to, because that's what we're going to do it now. Okay, we're going to do it like this. So this is the way we are going to be doing it for the other part of the approach. So do it like this.
I'm not.
Like, that was so much more easy.
What do we need?
Look, I thought I would have released. Yeah, because I need to do it. Yeah. Wait, so we go full of the what would be full beats? Like I do like the other side of the so like you use this guy. So 25 is what? Mole of things. Wow.
We learn it up in here, y'all.
Okay, for number 3.
Alright. It's very complicated.
How'd you do it?
All these numbers and letters.
All right, back to me. Working with me now. Thank you. Everybody, to start off 3, what was the first thing you wrote?
15B.
15 moles of B, because I really want you to write your units, because we're going to be using this. Ashton, what did you do next?
Oh, the little lines.
Lines, and then?
I put 3 moles of B on the line.
Where are you getting this 3 from?
The chemical.
The coefficient from the balanced chemical equation, good.
Yeah.
And then what'd you put on top?
5.
And ooh, where'd you get that?
The C.
So this is the coefficient from the balance chemical equation, right?
Yeah.
So this is a ratio, 3 to 5 ratio. So how did you mathematically do it? So 15 times 5 divided by 3. We can make this a little easier. What's 15 divided by 3? 5. What's 5 times 5? 25. You don't even need a calculator, right? Wonderful. Okay, so before I move on, I need to remind us to make sure we're all remembering the same thing. How do the mole can be related to 3 different things, right? So can you guys write this, draw this like I am on your paper someplace. Warm up is fine. So you guys have your relationships between moles, what, and what. What are the 3 mole relationships? So I have your periodic table, which gets us to what? Grams. Also we have what? Liters, and we have Avogadro's number. Okay, so put 1 mole. And let's just put A here just to represent an identity now, because now the identity matters. It's not just moles, it's moles of something. Okay? What's the first relationship up here? Okay, so 6.022 or times 10 to the 23rd goes to particles. Okay, which particles come in 3 flavors? Atoms and molecules. Okay, what's the second one here? Grams, which is called molar mass, but we get the number from where? PTOE, so periodic table of elements. And then the last one, volume, which is in liters, right? Liters. And how do I convert 22.4 liters? Add STP, good. Okay, so we know this, right? I want you to replicate this, but mirror it, reflect it, and do it here. So this is going to be moles, right? Put 1 mole, and let's just put B here to represent a different compound. What goes here? Particles, okay? And that's going to be 6.02 times 10 to the 23rd. What goes here? Grams. And what connects moles to grams? PTOE, okay? These are double-headed arrows. And what goes here? Volume. And that's 22.4 liters at STP. Good. Second?
Why'd you rewrite it? Like,
So I'm going to show you the magical connection between these. Okay, so there are so many things in reactions, right? We can make so many different products from so many different reactions. So we learned this stuff first, and then we learned how to predict reactions, right? So now we're going to put them together, because this example here, this represents a what? A chemical equation, which we know how to write now. We know how to predict the products. We know how to balance them all. So if I ever want to convert from, let's say, grams of product D to grams of product A, I have to have a method to get across this reaction. I have to have a method to get from D to A. Well, what's the method? You guys just told me how to do it. These mole ratios. So the D having a 4 and the A having a 2, those are now called mole ratios. So I have to find a way to convert moles to moles. That's really the stuff I don't have. Because I can get from particles to moles and grams to moles and volume to moles, but how do I get from moles to moles? What do I have to have in front of me to get this information? The mole ratios, which are coming from the balance chemical equation. All right, so connect these two now. Connect them now. And put BCE, meaning what? Balanced chemical equation, mole ratios. And the mole ratios are just the coefficients. So this is the only new piece we're learning today. Just this, which seems really simple. You're like, well, I got all this stuff, which is the same over here. It's just connecting these two together. So the rest is what we're going to apply today. With me? So that's what we have to learn how to write reactions. If not, we would have never had the connecting piece because we wouldn't have known how to balance a chemical equation. All right, so let's practice what mole ratios are just a little bit more, okay? So I have, I did print something for you. Let me actually pull this out first. There's a paper that you guys had lecture notes, chapter 11, reaction prediction. We did this. You're going to do this now, okay? So flip it over for me. Find this lecture notes now. Find the lecture notes.
What does it look like?
Oh yeah, we got
Okay, give me a hand raise if you can't find yours. Hand raise if you can't find yours.
Oh wait, I found
Okay,
it.
it's right there. What about okay. Now, do you see that I have the mole map for you right here? Okay. I wanted you to draw it because if you draw it, you should know better. You'll notice there are gaps in my mole map, right? You see the empty spaces? Can you fill those in for me? Fill those in right now.
Listen, no, I don't think I can. Listen, no, actually, no, here you go. You can have this one.
Guys, keep yourself a word on. I thought I did. I don't want to keep stealing trees. Trees are important.
I bet I can find it.
All right, so I gotta go ahead here. Okay, so this is what you have, right? You're filling in the gaps for me.
It is probably in the middle.
All right, give me a thumbs up once you fill in your gaps.
I'm not going to
Right.
Yeah.
Three particles of mole X, and you wanted to go to particles of mole Y. Could you skip the converting them to moles?
Actually, potentially, but I don't want to get in that practice because then you'll start skipping steps. Like you said, I could skip steps. No. You can't. Not. You have to follow the road, right? The road. So what Gwen is asking is, if I want to get to from particles like atoms of something to the atoms of something else, I'd have to follow the road. How do I get from particles? What's the only thing touching particles? Moles, right? How do I get from particles to moles? Avogadro's number. How do I get from moles of something to moles of something else? Through the mole ratio, which is from the Balanced-Chemical equation. How do I get from moles of that new thing to particles of that new thing? Avogadro's number. Now, even though writing it all out, you'll notice the Avogadro's number can cancel, which gives you the cancellation potential. Okay, so we're going to follow this roadmap. Okay. Any questions right now? You need one? Okay. So, oops, I'm going the wrong way. Can you guys tell me? Talk to the person next to you and tell me 4 mole ratios that this equation on the board represents. Give me 4 different mole ratios.
What's a mole? We did that in the
It's related
Like 282?
No, now I'm getting confused because I have the
Oh, there's just 2 birds.
when do you ever like cross your tracks back for
net ion equations. Net ion equations.
You have to do that. When am I going to
Okay, eyes back up here. There's a lull. We got it. Okay. So I can relate any reactant to any reactant to any product to any product. I can relate 2 things at a time though. So I specifically can write it this way, like for example, 3 moles of calcium react with 2 moles of iron 3 permanganate. Okay, so 3 moles of calcium relate or react with every 2 moles of iron 3 permanganate. I can write it like an equivalency because technically that's the recipe. Those are equivalent to each other. I use them at the same with that ratio. But in stoichiometry or dimensional analysis, we don't really write equivalencies like that. We always write them as fractions, right? So that's why I can specifically write this as a fraction as well. So in this one, I compared calcium to iron. I compared calcium to calcium permanganate. So I can stack it like this. Now, I chose to put calcium on top. What could I have done differently here? I could have put calcium permanganate on top, so I could have flipped that, right? Okay. And then this one I did iron. 2 moles of iron for every 3 moles of calcium. So I could relate anything here. Give me another one, Josh.
You could relate 2 moles of iron to
2 moles of iron, 3 permanganate for every 2 moles of iron, right? So it depends on how the question's phrased, which of these relationships we even care about, but we can do any of them. Give me a thumbs up if you understand that coefficients are mole ratios. Coefficients 3, 2, 3, 2 are the mole ratios. Question.
So, could you make ratios of elements that are in different formulas if they have one element, like that's the same in both the formulas, like their transitive property?
I think I understand your question. The answer should be yes, but that's called an internal mole ratio, where you're looking inside of one compound. That's a Reese cup example, I think is what you're saying. All right, I'll come back to that. Can I come back to that? Okay, so basically what you guys are telling me is that this recipe, which we know technically could represent particles and liters and moles, we're specifically focusing on the fact that these coefficients or the recipe are all mole ratios. Because I could equally say, okay, I have 2 moles of hydrogen reacting with 1 mole of oxygen reacting with 2 moles of, producing 2 moles of water. Or if I was talking about molecules, I could say 2 molecules react with 1 molecule to form 2 molecules of water. Or liters, right? Because these are all gases, they exist in big volumes. 2 liters of hydrogen react with 1 liter of oxygen to make 2 liters of water. But every single one of these, moles and liters, they all relate back to the mole. That's why specifically, since everything relates back to mole, we're just going to stick with those being called mole ratios. All right, some of you guys got it. We're going to keep working through this. Okay, so talk to the person next to you and give them 2 examples of mole ratios from this one. All right, and come back to me. 3, 2, 1. You had enough time to make 2 ratios. So, who feels okay now? Give me like a smile, a head shake, something like that, cheesy. All right, some of us are like grimacing. I'll get to you. Okay, we're going to work through these. Okay, we're going to skip down. This is the one we'll be using most of the time. I'm keeping on the board, so I'm going to reference this. Remember, no off-roading. We don't have like 4-wheelers here. We follow the road. Boom, boom, something else. It kind of depends on what the question's asking for. So I'm going to model one example all the way through, and then I'll take questions because I think that you guys will get it once you see it. Okay. So this is an example, and I actually have it on your lecture notes, which is right next door to your mole map that you guys see on your paper. So follow through with me here, okay? This question every single question that's reaction stoichiometry, which is the big word for chemistry math, requires us to first write the BCE. Okay, let's first write the balanced chemical equation. So it says the synthesis of aluminum oxide. So does it mean we're reacting aluminum oxide or producing aluminum oxide? We're producing it. We're synthesizing it, right? We're making it. Okay, so let's go ahead and make aluminum oxide first. Let's make aluminum oxide. What's aluminum oxide? No. Al2O3. What are we doing here? Crisscrossing charges. Please, please, please. Crisscross charges. Aluminum oxide is an ionic compound. You need to write this example down with me. This isn't just a watch and do the word. You need to do it with me, okay? All right, so we're synthesizing it from its elements, right? So this is a product. So from its elements means that these are the reactants. What are the reactants here?
Aluminum.
So aluminum meaning Al, and good, O2 oxygen, right? It's diatomic oxygen. Balance with the person next to you.
Two. No,
Put it to
You need a 4 and you get O and you get O.
okay, so you need to put a 2 in front of an A, or it's I just put a 2 in front of the A. I said this AL.
All right, come back to me. Come back to me in a second. So a couple of you guys are trying to squeeze your work on here. Don't recommend it. You're going to want to have some organized notes. So get some paper and teeny paper. I've got it, but you need to keep it organized so you won't be able to reference them very well. Okay. All right. So we have our reaction. Now, 4 to 3 to 2 is our ratio. So let's give me 1 mole ratio. Courtney, can you give me 1 mole ratio here? Choose anything. Just give me 1 ratio. 4 moles of aluminum to 3 moles of oxygen. Okay. Harshita, give me another one.
4 moles of aluminum,
2 moles of aluminum oxide. Good. Alicia, give me another one. So we did aluminum to oxygen. We did aluminum to aluminum oxide. Good. And so I know you guys are just telling me the numbers, but do say 3 moles and 2 moles because these are mole ratios. I chose to put aluminum, and oxygen on top. What could I have also done? Switch them, right? So I could flip this, depends on how the question's phrased, but I could flip this and call these overall 6 ratios. So 1, 2, 3 that are listed here, and then the flip version of that, which would be 6 total ratios. Question? Yeah, you can flip any conversion factor, any at a time. Just as long as your units cancel, we're good. Yeah.
will we ever have to do like 4 aluminum and 3
No.
oxygen equals how much?
No. We're only going to compare 2 things at a time, okay? All right, so now follow through with me on this next example. The questions are going to be like our word questions that we did back in dimensional analysis and with our conversions. So you know what this kind of means, but let's talk about it in reference to the reaction. How many moles of aluminum are needed to form 2.3 moles of aluminum oxide? Okay, so every single time you read a question, you must do 2 things first. Identify the question. Identify the thing I want to know. What is it? So question right here is, and write this down. Question, moles, aluminum. That is my question. All right, what is the one fact given? The one given. 2.3 moles of Al to O3, okay? So this is the given, and this is the question. Sometimes the questions tell you a story, and they tell you all kinds of stuff that's happening. Nobody cares. We just want to know the question and the given, okay? So which of these do I have to start my math with? Right, the only thing I have a number to start with was 2.3 moles of aluminum oxide, and I'm going to write mole fraction bar, okay? So at this point, touch where on your mole map, touch where moles of aluminum oxide are. It doesn't matter if you call it A or B, but just touch it. I'm going to touch moles of A. Okay, so I'm at moles. What does it say I want to get to? Moles of the other thing, right? So moles of one thing to moles of the other thing. So what's the connecting piece here?
The little mole ratio.
Mole ratio, Gauss rule equation, right? So this is the only thing I'm scanning is one step right here. So as I look back at my equation, I'm looking at these 2 things. Aluminum and aluminum oxide, right? So what is the ratio? So 4 to 2 or 2 to 4, but it does matter when I write it down. So who needs to go on bottom to cancel? So is that which one? The 2, right? So the 2 moles of aluminum oxide go on the bottom of the fraction. And who goes on top? 4 4 moles of aluminum. And I've made it from moles of one thing to moles of the other thing just by looking at my balance chemical equation. I'm done. I just have to calculate now. What unit cancels? Oxide, right? Moles of aluminum oxide, moles of aluminum oxide. So what's 2.3 times 4 over 2? What's 4.3 times 2? 4.6 what? Good. So 4 over 2 is just 2, right? So what's 4 over 2? 2. So what's 2.3 times 2? 4.6. So we just simplified it. I mean, you can do that part in your head, but you can also do it in your calculator. Okay? All right. Keep going with me, and then I'll take more questions. So, what is the unit asked for in C? Liters of what? It's very specific, right? You can't just say liters or just moles. You got to identify it as well. So, how many liters of oxygen, STP? So, I'm already hearing liters of STP. What kind comes to mind? What comes to mind when you hear liters? Right? So, you're thinking 22.4, right? So, you know you're going to use that sometime. You just don't know when yet. Okay? Blah, 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 blah. Okay? 0.84 moles of aluminum. So, like I said, the question kind of throw you off, but you've got liters of oxygen that's being asked for, and 0.84 moles of aluminum given. So that's your given. 0.84 moles of aluminum. So what do I have to start with? Right, the only number I have, which is 0.84 moles of aluminum. Now, before I problem solve, follow me on the board. So let's assume that my aluminum is like, the first thing I always have, I'm going to just call my A here. Okay, where am I starting at? Particles, grams, volume, or moles? Okay, I'm starting here, right? So this is moles of aluminum. Where do I have to go? I have no choice. Well, I can't go straight to volume because this is still volume of aluminum. That's not what the question's asking for. I gotta cross the bridge, right? So I'm gonna go from moles of aluminum to moles of what? Because the question is about oxygen. So this side of mine is aluminum, this side of mine is oxygen. And then I'm going to go from moles of oxygen to volume. So how many steps is that going to take? 2. 1 from moles to moles. 2 moles to liters. 2 steps. Got it? Maybe? Okay. So what am I writing on the bottom here? Moles of aluminum, because I have to cancel moles of aluminum. And like you guys said, I'm going from moles to moles. Well, where do I get the mole to mole ratio? From the balanced chemical equation. So I'm going from moles of aluminum to moles of oxygen, because that's what the question's asking for. What is the relationship between? What's the relationship? So for every 4 aluminums, I'm going to use 3 oxygens. 4 to 3. Okay, so you gotta have that ratio in front of you because that mine's way up on the board. So what was it? 3 for this one? 3 moles of oxygen for every 4 moles of aluminum. Write BCE on top of this if you forget that's where these numbers are coming from. I'm not just pulling them out of thin air. This is coming from the balanced chemical equation. Okay, so I've made it from effectively from moles of oxygen or moles of aluminum, moles of oxygen. Now I'm gonna go where? So what do I do here? What's my conversion? Does it go top or bottom? Top. 22.4 liters of oxygen for every. Right. Remember, this is 1 mole always. 1 is the only time we're ever going to change the mole number. It's never with liters and it's never with like grams because remember these are always 1s. Yes, when you're going from one kind of mole to the other kind of mole, you can change your coefficient numbers. But every other time, it's always a 1 for the mole. Calculate. Because the moles of aluminum cancel, moles of oxygen cancel. Look at this. Does anybody need a calculator? What we got here?
14.1.
How many sig figs? 2 sig figs, so just 14, right? Come on, Mac. You got this. I believe in you.
You need one? No.
All right, check yourself. And I want you now to repeat our thought process and explain the mole map to the person next to you. Talk it out. I'm coming around for questions right now. Ask them if they have a question. Ask them if they have a question.
That's not mine, so I'm really lucky, but I feel bad for everyone.
Yeah, I actually thought you were being sarcastic.
No. The binder thing just flipped.
I
Okay.
thought you were being sarcastic yesterday about your hair.
No, I was not. Okay. Okay, so joke, long list of heavy metals. Yeah. Mercury. Lead. Okay, good job, guys. Thanks for laughing. Okay, so I'm gonna do another one with you. Let's get everybody clicking here. Okay. So propane gas combusts. Think about what propane gas is. Write down the combustion reaction. If you don't remember it, I got you in like many.
That's not it.
Any elements at all.
What was it?
So it's 3 times 2, so 2.
So that's methane.
H comes first,
It's gonna be on the list.
Oh, reaction prediction. Yeah.
I don't think it's the.
How about focus for count?
Oh, I got it wrong. I need to learn my paints.
Many elements methane, ethane,
Are you on?
or no, meth, pro, and that. But are you taking a video of this? Oh, I kept saying A. It's no.
All right, and 3, 2, 1. Okay, so pro means how many carbons? Okay, so we have to say, so many elephants play ball. So meth, eth, pro, bute, everything else is like the normal prefixes, pentane, hexane, heptane, octane. So if it's an ane ending, how do we get the H's? So ane means 2n plus 2. And where do you get n from? The number of carbons, right? So 3 times 2 is, plus 2 is C3H8, right? So oxygen is our combustion reactant. You always use combustion of our production of carbon dioxide and water. Balance what first?
C.
So put a 3 here. So C goes first, and then hydrogen. So we put a 4 here, and then so what do I need here? 5. Okay. Please write down every step with me on the rest of this, because I don't want to like come to you and say I need help. I'm like, let me look at your notes. You don't have anything, because I'll just walk away. Okay. All right, so how many grams of oxygen are required to burn 13.0 grams of propane? When the question starts kind of getting long, you start getting lost. Okay, tell me the 2 things you're looking for. So the question, right? Grams of oxygen. So when it says grams of oxygen, does it mean O? No, it means what? It means O2. It's talking about this oxygen right here. Okay. So how many grams of O2? Blah, 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 blah. Who cares if we're burning something? We're like off in no man's land right now. So then we read, and this is our other part, which is called the given. So our given information is 13.0 grams of propane. Okay. What do I have to start with? 13.0 grams of propane. Touch your molar map. Mole map. Where we are. Touch where we are. I know yours are going top to bottom. I'm just going from right to left here. All right, so turn and talk to the person next to you and see if you can map out our journey. Map out our journey. They're starting at grams, right? Not moles. All right, and back to me. Where are we starting, guys?
Grams.
So we're starting at grams. What's the first step?
Go to moles.
How do I go to moles, though? So I have to use the molar mass of propane, right? All right, so who cares about propane? Where do I want? Where do I want to go? I want to go to oxygen, right? So I got to get from moles of propane over to moles of oxygen. So moles of something to moles of something else. What do I have to do for that? So I have to pull the coefficients, right? So I go from grams to moles, moles to moles, moles to grams. So I'm using the PR table again, but for who this time? Oxygen, not propane. So I already got rid of propane. How many steps? 3. Okay. 3 steps. All right, here we go. What goes on bottom? So you got that for me? 44.097 it is. Okay, so that's 3 carbons, which each weigh about 12. So that's 36. Plus 8 is about 44. So someone got real specific. Thank you. What goes on top? 1 mole of propane. Remember, it's always 1 mole of the thing until you get to mole ratios. That's the only time you change the mole number. Okay, so score, we canceled out what? No. We canceled out grams of propane. Okay, so now we're going to cancel out moles of what? Okay, so I'm going to put mole of propane on bottom. And who do I care about? Who's my question about? Okay, so I'm putting moles of oxygen on top. And then where do I get these lovely numbers? So point to the two we're looking at. That are propane and oxygen, right? So what numbers go where? 1 on the bottom, 5 on top. And then if you don't remember, like when you go back and look at your own notes, this is coming from the balanced chemical equation. Okay, so now moles of propane cancel with moles of propane. Writing this down with me so that you can have something to study later. And then I'm almost home free. I mean, from grams to moles, from moles to moles. Now what am I doing? Moles to grams. So what's the molar mass of diatomic oxygen? 32. Good. So 1 mole of oxygen, remember it's always 1 unless we're doing good coefficients, is 32 grams of oxygen. Because that's double oxygen. And then moles of oxygen cancel with moles of oxygen. Calculate. Okay, I was going to try this in my head, but you guys got this. Okay, 47 point what? So was it like, what was it? 168. Okay. So to 3 sig figs, because look at our 3 sig figs right there. You're good, you're good. Okay. Say again, math. So in our calculator, guys, what do? We got 13. So times 5, okay.
Times 32. Oh, no.
Times 32.
I thought I saw a 5.
Okay, you're good. So we're good now, right? All right. Work with the person next to you on the next one.
Hey there, buddy.
You got some people behind you.
All right, so I'm not and our given is 0.5. start with 0 times 0. MOL. We have to put like.
On your paper, there's a typo. Look at the one on the board. It says like acetylene gas on your paper, right? So look at B on the board because I never fixed that typo.
Yeah, perfect. Perfect. Oh, just kidding. I have that written down. Right here. We've gotten to the moles of B. That would write down, right? And then I'll give they're delicious. Why would they have 30 songs in it?
Focus. Focus.
Okay. What?
Guys, keep focusing. I'm trying to get us to get to our homework. Josh, what was your next step?
Okay, how did you get here?
Wait, no, the moles, not propane.
Help me out here.
I need an AP chemical.
No.
One more in water. Because you want to keep it
Where am I getting the one from?
from the sounds equation.
Oh, yeah.
All right, keep going, Josh. Keep going, Josh. Come on. What's on top?
On top is the 3 CO2. So the 3 moles of CO2.
Let's try to do that now in color. Okay. All right, Anushka, pick up.
So now you go from moles of CO2, you have 1 mole of CO2,
And now we can put the one, right?
the grams from the period. So
Oh, one. Something like that. Okay. And that's it, right?
and then you multiply.
All right, so in this one, if you're confused, you started where here? No, look at the given. We said at moles of A, and we're not going backwards. Nobody cares about A anymore. Nobody cares about propane. We got to go forward to who? So moles of B, which is moles of carbon dioxide in our example. So you had to use the BCE mole ratio first, and then you went from moles of B to what? Grams of B or grams of carbon dioxide, which is one more step using molar mass. All right, what's the moles here? And what's the grams here? 66. Thank you. Next to 266. Perfect. That's CO2. Good. So I'm canceling as I go in my head, but there we go. Got them all done here. Okay. Keep going. Go to C. And literally, I want to see you writing this out. Let's go. This isn't like in my head. I can do it. Let's go.
Because like I get how dimensional analysis works or whatever. Like you cancel everything out. So like this cancels this out. And then like what? So first like okay, so we went from this because we're going from mole A to mole B. Mole B is this. Let's see.
Oh.
Yeah. Okay. So this is mole A. Yeah. And this is mole B. I'm actually like fully okay now. Okay. So this whole time I'm like, what the heck? Why like? Alright.
I'm just trying. I'm barely touching it. It's on paper. Not touching it.
That goes on top. And that's what we're going grams to mole. But this one's oh, just grams to mole. We're going to liter. So grams to mole.
If I had a mechanical pencil, I would write it down. Because then
Is that all it takes?
Alright, so now one mole. No wait.
But like, can you help me before you write it? So like, we have.
Is it, don't we put the periodic table?
Oh wait,
I might be wrong. Just because like we have
it says 33
Guys, some of you guys are moving along faster than others. Go ahead and go to D. Like, go ahead and complete this. And then move on to the next question. I'm letting some people ask questions. Does it mean that you play?
alright, so now since we're at mole, okay, now I'm going to mole A to mole B. That's right down here. So mole B is so like grams of I don't even know if you're supposed to put that up there. That's
where's oxygen?
are you supposed to like put then we have to okay.
This relationship right now.
Because we went from that and then to here and to
Well, you have very
my life in a yeah, and then we're going to figure out the table. Yeah. And then more goes up here. And that was one. Oh, okay, whatever. Okay. So now it's on the mole. So we use the number to balance it. Wait, you have to use the mole.
Is the last multiplication?
No, you still have to go to liters.
Liters, so I gotta go down here.
Thank you for letting me help others while you proceed without distracting them. Thank you, thank you. Anybody want to help me out here? Answer was 33.0 liters of ocean. Good. All right. All right. So give me just give, I know where we are. Who has completed D? Okay. Some of us have, but others haven't. So if you have completed D, do not go to 3 yet because we're not going to learn molarity today. Just for those of us, actually, I'll go ahead and tell everybody this because you will be moving on here. So after we get through 1 and 2 on our lecture examples, drop down to where it says you try. Do you see you try down there? For today in class, which we have 20 minutes left in class, so we'll knock this out. We're doing 1 and 2 only. We're not going to do 3 and 4 today in class. So lecture examples, you try 1 and 2. Practice 1 and practice 2. Yeah, she wants to. Okay. So I'm getting ready to do this on the board after some folks get a chance to try. Yeah, so we don't finish. Let's get. We have 3 minutes. Let's go. We got it. All right. Have you guys done B?
No.
All right. What do you got C? I want to let you guys try.
But I can just go through the try.
Alright.
Oh, the you try.
Like easy, like you mess one thing up and you're done.
Yeah. How do you have the little BC thing?
Oh, maybe.
Oh, I was thinking Germany.
So, I'm not the water.
I don't know what I'm saying.
No, that's the hardest.
I don't know how to do it, so I can't go.
What's programming? Okay.
I thought it was going to be able to get all the
We're going to grams to yeah. Well, no. Periodic table needs to go on the left right now. So periodic table needs to go on the bottom. Yeah. So all we're gonna write on the bottom is 44.094 grams. Correct? And then above it is mole. 1 mole. And then 1 mole against that 1 mole. Well, actually not 1 mole. Yeah. You put 1 mole on the bottom. Yeah, 1 mole. H2O has so it'd be 4 mole over 1 H2O. Okay, so now we've got mole B. So it will be it's got part of it, so 6 point.
Yeah.
Ew. Stop, that's stupid. 6 point whatever goes on the bottom. Canceling it. Yo, I swear to you, 6.0 times the We're going to particles. We're going there. You're right. I totally just went out for it. Okay. Oh, this is that?
Yeah, this is that. It's just that.
So really it's 44 points.
Okay. Let me put this in bottoms.
So no, look. It's when it's talking about the number of particles, it's not one mole. So now we're it's like one mole is the balance.
Now we have to use the balance equation, right?
Yeah.
I'm so.
Miss Emma.
All right. Okay, this is for real, right? I'm about to throw up. Because if this is right, I will have to
This paper actually you don't
no, 5.46. Oh god, I can't explain it to you.
Oh, no.
You want to do a ball up here, ball up here, ball up here, ball. I still got a lot of stuff. Just follow the chart.
listen, look.
Yeah.
Like I'm confused about
I can't explain it. I really like get it like when you're like I watch YouTube.
Okay.
Do you get that?
How are you going to figure out this?
So is it just 5.46? Okay, let's do this. Let's move Please don't. I can't do that today.
Write this down. Where'd you write this down?
You didn't put that down?
Yeah, I have it.
Write it down on top of your paper. Because you have to have the balance chemical equation first to work.
Wait, why don't I know?
Because you guys didn't write it down.
Oh.
It was from paper one. Four.
Yeah, I do.
That's how you get them. Now, is that cleared up? Okay, Ashton. Can I write on the board real fast?
Alright, now
As
we're
other
getting
people can
into
see it
practice more.
I've been running around and not great.
Wait, what do you want us to do in practice? Whatever?
You try one and exercise 1 and 2.
Just one and two?
I've memorized it. Is it one? How much that way I don't mess anything up. That she got actually. You're doing the lecture. You're doing the bottom.
Oh, my brain's hot.
You're doing great.
What if you got 5.46?
You're beautiful. It's good.
I printed off.
Yeah, tutoring.
I can't do those. You said I can't do those.
Consider the decomposition. I did that. Oh, yeah.
Wait, so do we have to have balance
You put 2 moles? Why did you say? What is it?
K plus Alright. K plus balance equation. Consider sulfuric acid and chlorate.
It's not chlorate with on the.
Polylith.
Oh,
What is it?
ClO3, not 2.
Yeah.
Darn it.
I have my.
No, I got it wrong. You actually picked it right.
So what would it be?
I'm putting them together. It's not KClO.
It's a balance equation.
It's on the wrong side.
Not only it's a balance equation.
What's the charge?
Okay, hold up.
You know I'm not
But what's the charge like?
Oh, where's my pencil? Did I lose it?
Oh, it's right here. It's right here. Okay. Don't worry. It'll be better. Alright. Okay.
You were right.
I don't know.
What is the mole ratio between potassium chloride?
Did you get the second one? The second one? No, I mean, balance equation.
Well, it's specifically talking about.
Can I look up here so can mine can look neater?
So it's the same amount of potassium chloride in the carbon. You put the same amount of
Silicone.
Alright.
That's fine.
How many are there?
How there can be multiple ratios. This is the only oxygen. This is the only oxygen. So it would be.
I was expecting it to be like,
I don't know. She hasn't gotten it.
or minus
Wait, carbon? I'm just writing the equation. I can't spell equation.
No, I mean, like, that's it.
I'm just gonna.
I'm not gonna try. I don't know those words you're just
The examples are all fine. I wrote all everything back in the slide. Okay.
Alright, I don't want to let you leave unless you have this reaction completed. What is the decomposition of potassium chlorate?
2KClO3.
Hold on, potassium chlorate, KClO3. All chlorates decompose to form what gas? And a metal chloride. What's the metal chloride? Okay. Okay, you have to have the ratio right or all your answers will be wrong, right? But you still get your process. Right, what's the other, look at example 2. Look at example 2. This one's no question. They tell you exactly what it predicts. Garrett, give me one. Give me the reactant. For part 2, practice 2. No, we already did that one. Give me practice 2.
Like the equation?
Yes, so silicon monoxide, right? I mean dioxide plus, so just carbon. I'm going to just write the reaction. You guys can balance. So plus carbon yields,
silicon carbide
so silicon monocarbide, so 1 carbon, okay?
plus
So carbon monoxide is CO. You guys can balance from there. Okay. So what I'd like to show you is before we go, you notice I did not give you your reaction prediction quiz today, right? You notice that. So I did that on purpose because in intervention I reviewed with 3rd period. Okay. So tomorrow I'll review with you and we'll take your quiz tomorrow.
I like that.
Okay. So I felt that was more fair. So we're plan that you guys have. These are all covalent. You have 4 reaction predictions, and I'm changing it from 3rd period because I already have people who communicate in 3rd period. So before I wrap up here, notice that for homework is examples. You try practice 1 and 2. Who's almost done? Okay? And I want you to begin and concept 12. That means just look at the first couple examples and try to do those. 1 second, okay? I put under homework as well, selfies with scientists. Has anybody looked at those?
Yeah.
Okay. So chemistry project, selfies with scientists. Yes, you have to take a selfie. Yes. Okay. So if you guys have got to be quiet. You guys have got to be quiet. You're no longer talking to anybody because I don't want to have to hold the class after school. You guys done in the back? Aishi, Anushka, you guys done? Thank you. So the idea is that you can make contact with a professional STEM-related person. So it doesn't have to be science. It can be science, technology, engineering, or mathematics. And you're going to go through me first to make sure that I clear them, so don't start interviewing people. But you will do an interview with them. I want to know your questions. I want to know who you want to interview. If you don't have contacts, I've got contacts. So you can Skype with them. You can do a face-to-face interview with them. You can do a phone call, but the selfie's going to be pretty boring, right? Right? So the idea is that you can still have a professional conversation and learn something about science in the real world. Now, science and technology, engineering, mathematics all relate to science. So you can look through ahead, get ahead here, but I want to know your professional email. Like, I want to see how you'll craft your email before you send it to them. Okay, this isn't due till like December 12th or something like that, but that gives you like some holiday time if you need it. But yeah, you're using a real person. Bye.
No, like, I meant, so it could be like a family member or
Excuse me?
someone.
Individual. You guys, I mean,
Like a cousin or.
yeah, bye, thank you. Yeah, it can be, but it's somebody you know if you want to contact. If not, I have some contacts. Okay. Bye, guys. I am not. My sister is. My sister is, and she agreed to Skype.
So, I think regenerative medicine would get you